So your period in this case would be 2 pi over 3. And now I have that written down. Then I would look at that negative pi over 6 and go, well, that makes it go right. Pi over 6. And I look at that negative 1, and I would say that would make it go down. I graphed absolutely nothing, but that's worth points on the test. That's worth a lot of points on the test without graphing anything, because you're telling me what should happen. First of all, I see that the amplitude is 1/2. So some of you might have done 1 and negative 1, and then 1/2 would be there, which would be such a small move. So instead of doing that, I'm actually going to mark it 1 up here, negative 1 down here. Then I have more movement within my graph. What I'm going to do first is I'm going to draw the new sinusoidal axis. The new sinusoidal axis goes down 1, negative 1. That way I know my graph is going to be shifted down. Then I'm looking at, okay, we have an amplitude of negative 1/2. Negative flips it. 1/2 makes it so it can only go up 1/2 and down 1/2. So in fact, I'm just going to take care of that. That's all I'm going to do. What's a major step I missed, though? Not right. There's something not labeled that people are going to forget to do. Safa? Labeling the tick marks on the x-axis. Think you lose points on the test for that? Yep. I'm going to do that now. Okay, the period is 2 pi over 3. So you count out 4 tick marks, kind of. 1, 2, 3, 4. And we write 2 pi over 3. Then to get halfway, you just divide that by 2. So you have 2 pi divided by 3 divided by 2, which is pi over 3. Then we go pi over 3 divided by 2 again, which would be pi over 6. Then I multiply by 3 to fill in that third tick mark, which would be 3 pi over 6, which is actually pi over 2. All right, I'm going to do a graph of just the amplitude and the fact that it's flipped. So that's all I'm going to do right now. So it's a sine graph. So it starts on the origin of the sinusoidal axis. Instead of going up, it's going to go down 1/2. Then it's going to go back to the sinusoidal axis. Then it'll go up, and then it'll go down. All right, then all I have to do is shift it right pi over 6. Good thing pi over 6 is already labeled. So that's going to shift all those points, basically 1 tick mark over. Move that guy over, move that guy over, move that guy over. And now I'd go back to these comments. Is it down 1? Yes. Is it shifted right? Yep. Is the period 1/2? Yep, the distance between those is 1/2. Pretty sure I'm correct as long as I have the period correct.
Oh, wait.
Nope, it's down. It's down. I see, because this is actually 1/2. So it actually is down 1. I just did that, so if I didn't do that, it'd be like this tiny little, which is fine, but it wastes a big chunk of the graph. So even me showing this to you, I drew 2 graphs. But several of you only draw 1 graph. And I guarantee the people that are just drawing 1 graph are probably going to make major mistakes on the test. And without any other graph supporting it, you lose the most points out of anyone. Okay? All right, questions on the bell work? Okay, then we'll go over that problem. Number 29. Number 29. 29. Is that right? Is that 29 in Spanish? So I did almost everything correct. So I shifted it right pi over 3 units. I should. It was minus pi over 3. I shifted it right pi over 3 units. I haven't made my marks because this is pi over 6, pi over 4, This is pi over 3. If you look at a unit circle, pi over 6 comes first, pi over 4, pi over 3. So I did all that right. I have the amplitude as 2. It is 2. My big mistake was I didn't flip it. It is negative 2. So the only thing wrong was it should have came down. It should have went down, back up, back up, back up. So it should have been that red answer. Yeah, so.
Doesn't it say +1?
Oh, yours says +1?
So yeah, maybe shift it up.
Oh, mine doesn't. I must have made a shift since last year. Yeah. Well, that wasn't on purpose. And then what was it? 1, 2. 1, 2. So it'd be down here. And then it'd be 1. So to go off my graph. So yours is a +2 on it? Or +1?
Yeah.
Good to know. I'll have to change that for next year. The other class did not tell me that. All right, so it should look like that. But the other one should be fine. All right, other questions on the homeworks, though? Yeah.
37.
37. 37. Yish. What's your question?
I think on the answer key it said like amplitude of 2 or something. I was like confused.
It should not be an amplitude of 2. So that is a mistake you get a point for. It should be amplitude of 1, right?
Yeah.
Yep. Number 37 should have an amplitude of 1. So you'll get a bonus point for that. Other questions? Nora?
41.
41. How about we do 43, because that's the one I left blank. Sure. I left 43 blank because it was supposed to be the hard one. And then when we do 43, then you can do 41 on your own. I'll give you one to be able to practice. So 43 says 2, let's go back to black. 2, 2, -1, 9er. All right. And then according to the direction, it says it has the given period, phase shift, and range. So this 2 is going to be the period. This 2 here is going to be our phase shift. So since it's positive, positive is going to say go right. 2. And this is our range. Let's talk about that range really quick, because it's probably been a while. Range is your lowest to highest point on your graph, your lowest y value to your highest y value on a graph. So if you picture a regular sine curve in your head, it bounces somewhere between -1 and 1. It just keeps bouncing back and forth between -1 and 1. Well, this says now it's bouncing between -1 and 9. So just coming up with a general idea graph of this. So we'll say this is -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Got it. All right, our graph is bouncing somewhere between that -1 and 9. And I don't care how it's doing it. We just know it's going to look something like that. That's all that range says, is it's bouncing between that -1 and 9. Well, smack dab in the middle of -1 and 9 is our sinusoidal axis. Smack dab in the middle is our sinusoidal axis. So if we have -1 and 9, the difference between -1 and 9 is 10. So halfway between those would be 5. So 9 minus 5 would be, so right at 4, we would have our sinusoidal axis. 1, 2, 3, 4. That right there would be our sinusoidal axis. Yeah.
I'm sorry, how did you get that?
Magic. That's not good enough of an answer?
Good enough, I'm sorry.
Aw.
I wish it was, but it's not. I apologize.
All right. Our sinusoidal axis is always in the middle.
Yeah.
It's always in the middle. So if you wanted to just count between them, that's fine.
Okay.
But to get the exact middle of it, what I do is what's the distance between 9 and -1? To get the distance between two things, you subtract them.
Yeah.
So I'd have 9 minus a -1, which comes out to 10. And then you take the absolute value. Because let's go the opposite direction. -1 minus 9 would be -10. Take the absolute value, and you now have a distance of 10.
Yeah.
To get halfway between there, you just take 10 divided by 2, which is 5.
Mm-hmm.
So the distance to the midpoint is 5. So you just add 5 to here. 1, 2, 3, 4, 5.
Okay.
Or you subtract it from 9. 9 minus 5 is 4. I might have not said that completely.
It's okay, thank you, yeah.
Mary, do you still have a question?
I was just confused, like, why it changed from 5 to 4, but I get it now.
Okay, good. Yeah.
So 5 is 5 is not 10, so 10.
Yep. So the distance between 9 and -1 is 10 units. So the distance between -1 and the midpoint would be 5 units, which is 4. Because -1 plus 5 is 4. Your goal is just to find that midway point. Yeah.
I found it a different way.
Cool.
So I did -1 plus 9 to get 8,
Mm-hmm.
and then divided that by 2, and I probably switched to for values.
Uh-huh.
I don't know if it worked for everything.
Nope.
No, it didn't.
Worked for this one, though. All right, so our sinusoidal axis, sinusoidal, I think it's about that right, is right there. Let's remember what we're looking for. We're looking for an equation with an A value, which is our amplitude, a B value, which will get us our period, C value, which gets us our left and right, and finally our D value, which gets us up and down. They give us left and right. So let's just talk through this as we do this. So let's get our amplitude, so our A value. Our amplitude is the distance from the sinusoidal axis to the top. Yeah. It's going to be 5. In fact, that's the exact number that we came up with. It's half. It is always going to be half. Our total distance is always going to be our amplitude. So our amplitude is 5, so that is my A value. Let's talk about the period. This is the hardest one to get. The period in this case equals 2. That is not my B value. That is not my B value. Because remember, the period is actually 2 pi divided by B. Our B value is embedded in that equation. You're going to set that equation equal to 2. Because that was our period that we found. And then you just solve for B. Then you just solve for B. So we have A equals 5. We're going to solve for B. Multiply both sides by B, and you'll have 2 pi equals 2B. Then we divide both sides by 2, and you'll have B equals pi. Mary.
Sorry, I'm still confused. Like, what does B equal? Because I'm always confused on how to find it. I guess that it's 2 pi over. Where do you get B from?
Where do I get? Well, I got it here, I guess. It depends on what information you know. If you know the actual period, so our period is 2, you're just going to set 2 pi over B equals to 2.
And then you just figure out.
And then you just solve for B.
Okay.
So in this case, I multiplied both sides by B, Mary, to get 2 pi equals 2B. Then I divided both sides by 2, and I get B equals pi. So with B, you'll either know the period, or you'll actually already know your B value. All right? In this case, we knew the period, so we had to find B. All right, so we have our B value. Our C value. Well, our C value is just right 2. So our C1 is just going to be our right 2. And our D value is up or down. We need to shift up 4 because our sinusoidal axis tells us what we got shifted up or down at. So it's going to be up 4. So our d value is 4. In order to come up with a sine function, you just need a, b, c, and d, and now we have everything. So we can just go to y equals our a value, which is our amplitude, which is 5, times the sine of our b value, which is pi, times x. To go right to it is actually minus 2, and then it's going to be plus 4. Yeah?
How'd you get the d value again?
Made it up. No. Our sinusoidal axis usually starts at the origin at 0. So if it's up at 4, it must have had a shift up 4.
Okay.
And so it's our d value must be plus 4.
Okay.
So once you find your sinusoidal axis, that's whether you're up or down. So if our sinusoidal axis is down 10, it would just be minus 10 here in this place. Emma?
Doesn't it say the shift is 2 though?
The shift is 2. Yes. Right 2.
Oh. That doesn't have to do with That's fine.
Are we good? You trailed off there for a second. All right, take all that into account and then try the one prior. That'd be my advice to everyone out here, because this type of problem is probably missed by at least 50% of you. And in fact, I looked around when I was teaching it, and some people just waited to put down the final answer. Good luck. Good luck replicating that if you took no notes and just wrote down the answer. Especially because we're going to do more of it today. All right, other questions from the homework? Okay, then let's do this all over again. But this time we're going to do it with the drawing. So that's the next problem we're going to do. We're supposed to write an equation of the form y equals a times sine of b times x minus c plus d. All right, that means I need an amplitude. I need to know the period. I need to know left or right. I need to know up or down. Here's the one thing about a problem like this. We all might have slightly different answers, but it can be correct. It all can be correct. So what I mean by that is they're asking for a sine equation. Sine either goes up, down, and back up, and then stops. That's one cycle. Or it can go down, up, and then stop here. Notice here, they have extra stuff. In fact, I could write over and over and over again. My advice to you on this problem is find one cycle of sine you want to write that equation for. So what I'm going to do is I'm going to cross out that little bit. This is one cycle of my sine. This is all I'm going to focus on. That is exactly what I'm going to use to find my amplitude, the period. I'm going to go ahead and find my shifts up and down. So the first thing I'm going to do as soon as I have this is I'm going to draw a sinusoidal axis. Because that sinusoidal axis is going to give me my amplitude and it's going to give me my up-down direction. That sinusoidal axis is down 1. So that means my d value is negative 1. It goes down 1. That blue line I just drew is my amplitude. In this case, the amplitude is 2 units. So that means the a value is going to equal 2. You already know how to do this? All right, so we have our d value and our a value just by drawing a sinusoidal axis. That's all I needed to do. Let's tackle the period next. So the period is from start to finish of one cycle. So that period is this distance here. Let's go ahead and do that in blue as well. Do you have that? Or do you have a question?
Yeah, I have a question.
Yeah.
Can you do what, plus or minus amplitude?
Plus or minus the
'Cause
amplitude.
On one part of the graph it goes down, which is what you're doing. But
Yes.
it goes-
You know, like I said, we might have, if you choose the other one, it'll be a positive amplitude. And if you choose the one we're doing, it's going to
Will
end up being
everything
negative.
else be the same?
Everything else will be pretty much the same. No, it won't all be the same.
Oh, okay.
Because we're going to have different shifts.
Right.
Because I need to shift it all the way over there.
Okay.
All right, so that period, we need to figure out that distance. That distance is, it is not 2 pi. It is not 2 pi. Yeah, it is pi. It actually is pi. That distance is pi units. And I think one way to think about this, see this is pi over 2? Half of pi over 2 is pi over 4. So right here is negative pi over 4. So each one of these tick marks is pi over 4 units long. Just like when you have an x-axis that goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, each distance is 1 unit. It keeps increasing by 1 unit. So this is pi over 4. 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 There are 4 pi over 4s between here. 1, 2, 3, 4. 4 pi over 4s equals pi. Yes?
Maybe another way to do that, because I did it.
Yes. Yeah, well, how'd you do it?
I shifted the 3 over so it was on one axis,
Yep.
and then just multiplied by 2.
Yep. That'll work. Another way you can do it is just line these up with from pi over half to the pi over half, that's pi units. Or you can mark each of these and actually do the math between them. But that distance is going to be pi units. So we have our A value. We have our D value. We're going to use the period and the fact that period equals 2 pi over B to say, well, 2 pi over B gets me my B. The actual period is pi units, so I just need to solve that, and I'll get my B value out. If you solve that, you're just going to get B equals 2. That is my B value. So we have A, B. Now we just need our C value. Our C value is our shift. And usually this would be on our y-axis. Now it's way over here. How far did this move? How far did that move? Let me just do it in purple. So I'm looking for this distance here. How far is that? Mary? 3 pi over 4, right? It moved 3 segments of pi over 4. So that is 3 pi over 4. In other words, this must be 3 pi over 4 as well. So C is going to be that 3 pi over 4. All right, now we just do our equation. Y equals, notice it goes down first, so it is reflected. So it's going to be negative 2 times sine of the B value was 2. And then we'll have x, and then we'll just make sure, okay, it's going left. 3 pi over 2 left is a positive 3 pi over 4. And that's going to be minus 1. I kind of skipped that. Mike, do you understand why it's pi instead of 2 pi?
Yeah.
I just want to make sure, yeah. Nothing worse when you give an answer in class and someone says it's, and it's just like, nope, you're wrong. She's right. And just, I don't know why. Questions on that? Yes?
I do not get that. I don't know how to 3 pi over 4.
Because, are we doing the same one?
No, I did the other one better.
So you will have a different answer than me. So if you did, so I'm assuming you blocked this part off and took this part.
Yeah.
So you are going to have a shift, so yours is going to be plus pi over 4. And yours will be positive.
Okay.
Yep. So what Safa's talking about is, let me erase this real quick. What Safa did is she basically crossed out this section and she focused on this, which would have a different shift. It wouldn't be flipped, so it'd be slightly different. So when you look at the answer key, mine might be slightly different than yours. The period should still be the same, so our B value should still be the same. Our amplitude should be the same, but the other numbers might be a little bit off. So make sure you take your time and check to see if yours was right to begin with and mine was just a different version. All right, questions? All right, everything you got today is not homework tonight. It is broke apart into 3 different assignments. And you can actually see the natural breakpoint. So if we started on page 39, 40, 41, that's all part of the same assignment. So that is your homework tonight. If you look right after 41, there's a blank page. That's kind of your stop point. Then you get to section 5.3D. That is what you're working on tomorrow in class. Front and back.
The page
Starts at 55. Oh.
43 and 44.
Wait, 39 and 40?
As far
39
Page
is what we
All right, everyone just stop. 39 is what we just did. It's on the board. That's page 39. Then behind it's 40. And then there's 41. That is all due tomorrow. Then there's a blank page. That's your stop point. And then on page 43, it says section 5.3D. Front and back is what you're working on tomorrow during class. Then you have a chapter review. That's what you're going to work on Friday, and we'll also work on this on Monday. Then you'll have a test on Tuesday. All right, so you have everything you need until your test on Tuesday. And realistically, this is just a pacing issue because I'm not going to be here to check your work. So rather than having everything due Monday where you're doing everything Sunday night, that's the pacing I would do it at. I would do that first section at 5.3C, get all of those done, and then tomorrow in class, work as hard as you can at 5.3D and get that done for homework that night. Then you just have to worry about the review for Friday and Monday. Any questions on that?